Okay, hi all. We're here on SIG number 10, which has to do with inverse derivatives and the fundamental theorem of calculus, part 1 and part 2. It actually starts with the fundamental theorem of calculus here, right? So we're given f of x, and they want us to find f prime of x and simplify our answer, right? So basically, to find f prime of x, we have to take the derivative of both sides. So I'm going to write that out, right? The derivative of f of x, and on this side we have the derivative of this. And the nice thing is that the derivative and the integral are inverse processes, right? So what's going to happen with these, and you can actually check this, right? You could actually integrate this and then take the derivative, which we did in class, but I don't want to make this video too long, but the idea is that the derivative cancels the integral, right? So like this is going to cancel this. And the thing that happens is, if you imagine, like if we had integrated this, we would have had to plug this x into that function at some point. And so like the leftover equation would be a function of x. So like this x is actually going to replace any t values we have in there, right? So what it ends up being is just -2 over x squared, right? Because the integral and the derivative cancel. You're just left with what you started with, except the variable is now that other variable that was up there, right? And then on the left hand side, the derivative of f of x is f prime of x. Whoa. So we have f prime of x like such. There's no negative on it, right? So it's pretty straightforward one. In this case, we have something that's like a function up here, right? It's not just x, but it's like x cubed. And so what that means is, like, if I, let's write this down. If I take the derivative of an integral of something with the u, which means it's not just x, then the leftover thing is going to be f of u. So whatever this variable was inside gets replaced by the u that's up there. But then because of like chain rule, you also have to multiply by u prime, right? So in this case, we're going to take the derivative of both sides. We're going to get f prime of x equals, the derivative of the integral cancels, and we're left with this, but replaced with this x cubed. So it's going to be x cubed here and there, because those were t values, and then we have to multiply by the derivative of the inside. So the derivative of x cubed is 3x squared, right? And then the instructions do say simplify, so we just need to do this. It's going to be x to the 6th plus 6x to the 3rd plus 8 times 3x squared, which is going to give us 3x to the 8th plus 18x to the 5th plus 24x squared, right? This is our derivative. All right, so it's, pretty straightforward. You're just recognizing that the derivative is going to cancel the integrals, and then how to replace that upper limit in there. Okay, so let's keep going. The next one is, we want to find that's inverse and that's derivative. So we want to find the derivative of the inverse function, right? And so what we learned at some point was that an inverse function basically happens when f and g are said to be inverses if f of g of x gives us x. And so what we did is we actually we differentiated both sides, right? We took the derivative of both of these, and we got that, using chain rule, we get f prime of g of x times g prime of x equals 1, and we divide both sides by f prime of g of x, and so we would get g prime of x equals 1 over f prime of g of x. Now you don't have to do this on this SIG test, but I'm just trying to show you what this means, right? So up here we said that f and g were inverses, right? So g is the inverse of f, So right here we're finding g prime, which is the derivative of the inverse. Right? So if I want to find the derivative of the inverse, I do 1 over the derivative of my original function evaluated at my inverse. And the relationship inverse functions have is that if the point, let's say if f of a equals b, then g of b is going to equal a, right? And so we'll use that over here, right? We're trying to find f inverse prime of a, right? So basically what that means is f inverse prime of a is going to equal 1 over f prime of f inverse of a, right? It's the same thing we have written over here, except instead of g of x, we're writing f inverse of a, right? If you want to write the g of x and say that it's the inverse, fine. So the first step to this is we need to find out what is f inverse of a, right? So again, like f inverse of a means that if f inverse, let's say if f inverse of a equals b, that means f of b equals a, right? There's some number b that we plugged into f and we got a, right? So what that means up here is we actually have this function f. We're trying to figure out what's the b, right? Because we want to know this b so we can replace this whole thing right here with b, right? So what we're going to do is we're going to set 6, because a is our output now, so 6 in this case is this, equals 3x cubed plus 3, right? So we took the given number and we replaced it in for f of x, because that's the output we're trying to get, and we're trying to figure out what x value will give us this output. So now we solve this equation, and you're going to subtract 3 and divide by 3. We're going to get 1 equals x cubed. And so we ask ourselves, well, you know, what numbers cubed give us 1? Well, x equals 1, which is basically our b, right? So what we can do now is rewrite this and say, well, f inverse prime of, I guess in this case, 6 is 1 over f prime of 1, right? Because of this, right? So basically what we're saying is f of 1 equals 6. Therefore, f inverse of 6 equals 1, right? So we replace this f inverse of 6 with 1, right? We replace this with 1 because we found that that was that. Okay, we're not done yet, so we still need to find 1 over f prime of 1. So that involves taking the derivative and plugging in 1, right? So let's go and take the derivative, right? I'll do that down here. F prime of x equals 9x squared. F prime of 1 is going to equal 9. So our final answer here is going to be 1 over 9, like such. All right. Let's keep going. We're going to learn how to take derivatives of inverse functions and integrate inverse trig functions at some point. So that gives a good opportunity to talk about that. The derivative ones and the integral are basically things that we just need to try to memorize. They show up a bit on the exam, you know, a few questions here and there, and so they're good to know. They are on that sheet of derivatives that I gave you towards the beginning of the school year, right? There's all the arc functions. I think you should only need to know sine, cosine, and tangent, arc sine, arc cotangent, and arc tangent, and we'll go through some examples with it. So for cosine, if you see it on our sheet over here on the left, the derivative of arc cosine is negative u prime over the square root of 1 minus u squared, right? So in this case, our u is this inside thing, right? So it's just basically applying this formula. The derivative is going to be negative u prime. So u prime in this case is 20x to the third, right? The derivative of that. So it's going to be negative 20x to the third divided by the square root of 1 minus u squared. So u squared, which is going to be 5x to the fourth squared. And it's fine if you want to leave it like that. You could also write 1 minus 25x to the 8th, right? But that would be it for that. Okay, so I just want to run you through a couple examples. Let's pretend it was sine inverse of 3x squared, right? Then we'd look at or you have to memorize these, but the derivative for arc sines over here on the left, right? Look for it. It's basically going to be u prime over 1 minus u squared. So it's very similar to cosine, except it's positive instead of negative, right? So u prime is going to be 6x over the square root of 1 minus 3x squared, right? And again, it was u prime over 1 minus u squared, square root of 1 minus u squared. That's how we got that. Okay, and then one more example, because this might pop up as well, is just like maybe a arctan, so tan inverse of, I don't know, let's just do kind of a funky one, e to the x, e to the 2x, how about that? So tan is just u prime over 1 plus u squared. So u prime in this case is going to be 2 e to the 2x, right? That's the derivative of e to the 2x over 1 plus e to the 2x squared, which we could simplify to e to the 4x, like that. Right, and so that would be the derivative of that. So like if you know the formula, then it's pretty straightforward about how to do it. Okay, and then next we want to be able to integrate. And so we have to recognize which of these functions it is. So let me get the formulas up real quick, and then I can show you that. Okay, so for the integrals, there's only 3 you need to know as well, which is arctan, or tan inverse, arcsine, and arcsecant, right? So arctan is, if you start with the du, or u prime, over a squared plus u squared, then it's going to go to this 1 over a arctan u over a plus c, right? Because it's indefinite. And then if you have a square root, then it's going to be arcsine. If you have a square root with a u on the outside, then it's going to be arcsecant. And just notice how the a and the u's are arranged inside the radicals as well, right? So I highly recommend writing these down if we haven't talked about this yet in class. Right, so the first piece is like we need to recognize which one we're dealing with, right? Like which one of these matches that down there? Well, it has that extra thing on the outside there, right? So that's this u. And so we can recognize that in this case u is x, in which case this is u squared, right? And then du would be the derivative of x is 1, and that's what's up here is 1, right? So basically this is just going to go to 1 over a, right, where a is this number, times secant inverse of the absolute value of u over a plus c. So in this case a is 1, so it's going to be 1 over 1. Secant inverse absolute value of u is the absolute value of x over 1 plus c, right? And so you don't need that because that looks like an integral. That would be that answer. Okay, so let's look at other ones. Let's look at what if we had let's say let's say 1 over the square root of 9 minus x squared, right? Then you have to recognize, okay, well, this is the sine one, arcsine. Look over at the things over here, right? Arcsine is du over the square root of a squared minus u squared. We have to recognize that it's 3 squared minus x squared. So our a is 3 and our u is x. And so the integral of this would be 1 over a. No, I'm sorry. There is no 1 over a for sine. It's just arcsine x arcsine of u over a. So u was x over a plus c. There's no absolute values on that one. Right, and then we'll look at one last one. What if we had the integral of 1 over 25 plus x to the fourth dx, right? And like we're like, oh, well, that doesn't look like any of these. Well, he could make it look like an arctan, right? So we could make it look like 1 over 25 is 5 squared, and then we want to write x to the fourth as something squared, which is just x squared. And so this would be 1 over a, which is 1 over 5, tan inverse arctan of u over a, which would be, in this case, x squared over 5 plus c, right? And that would be the integral of that one, right? So you just have to kind of familiarize yourself with these formulas and the ones that look like arctan and all that stuff. And we can explain why these formulas are the way they are, maybe at some point using like this, what we did up in question number 3 with the taking the derivative of an inverse function. Okay, I hope this is helpful. Good luck.